Welcome to the DIY Honda Garage channel. Welcome to the diagnostics session for the DTC P0192 concerning the fuel rail pressure sensor circuit low voltage issue, specifically for the Honda Accord models from 2012 to 2017. This diagnostic trouble code signifies a malfunction related to the fuel rail pressure sensor, which plays a critical role in monitoring the engine's fuel system. The fuel rail pressure sensor is designed to sense the fuel pressure in the rail and convert that measurement into electrical signals that inform the powertrain control module, or PCM, about the current fuel pressure status. This information is vital for the PCM, as it adjusts the operation of the high-pressure fuel pump solenoid to maintain optimal fuel pressure. If the sensor's output voltage remains outside of its designated range, it prompts the PCM to detect a fault and store this DTC. The subsequent slides will provide a detailed breakdown of the error description, potential causes, symptoms, and comprehensive troubleshooting steps for restoring normal function to this crucial component of the fuel system. Post-repair verification is a vital part of the diagnosis and repair process for DTC P0192. Once repairs have been completed, it is essential to erase the DTC from the PCM. This can be accomplished using a scan tool, which allows the technician to clear any stored fault codes and reset the system. Following the clearing of codes, a test drive of the vehicle should be conducted to ensure that no codes reappear and that all systems are functioning as intended. Carefully monitor the vehicle's performance during the drive, paying special attention to the engine's responsiveness and any warning lights. If all diagnostics pass successfully without the return of DTC P0192, it indicates that the repair was effective. Continuous monitoring of the fuel delivery system post-repair is recommended to ensure long-term reliability. Preventive maintenance is key to avoiding future occurrences of DTC P0192. Regular inspections of the fuel system, including the fuel rail pressure sensor, can help identify potential issues before they escalate into larger problems. Technicians should routinely check the physical connections and wiring associated with the fuel rail pressure sensor to prevent damage from environmental factors, such as moisture or corrosion. Ensuring voltage supply lines and ground connections are secure promotes the reliability of the sensor. Additionally, performing regular maintenance on the PCM software can enhance vehicle performance and prevent misreadings or confusion triggered by outdated programming. By implementing these preventative measures, vehicle owners can prolong the life of their fuel system components and maintain optimal engine performance. In conclusion, DTC P0192 serves as a critical alert regarding the fuel rail pressure sensor's functionality within the Honda Accord 2012 to 2017 models. Understanding the responsibilities of the fuel rail pressure sensor and its interaction with the PCM is essential for effective diagnostics and repairs. Tracing the possible causes, such as an open VCC line or sensor failure, highlights the importance of thorough troubleshooting steps. From verifying ignition status to examining the PCM, recognizing the associated symptoms not only aids technicians in identifying faults, but also helps in communicating possible issues to vehicle owners. Lastly, regular preventive maintenance can mitigate risks associated with this code, ensuring that the vehicle continues to operate at its best and maintaining the safety and efficiency of engine performance. Emphasizing these key points will contribute significantly to effective vehicle maintenance programs and customer satisfaction. The fuel rail pressure sensor is an essential component of the Honda Accord's fuel delivery system, and its primary role is to monitor the fuel pressure within the fuel rail. It is positioned directly in the fuel rail assembly, where it can effectively sense the pressure of the fuel that is being delivered to the engine. The sensor converts the measured pressure into electrical signals, which are then sent to the powertrain control module, commonly known as the PCM. The PCM uses these signals to control the high-pressure fuel pump solenoid so that the fuel pressure remains within specified limits under various operating conditions. When the voltage output from the sensor falls below a threshold of 0.31 volts for at least 1.5 seconds, the PCM identifies this as a malfunction, leading to the setting of the DTC P0192. Understanding the role of this sensor is crucial, as a proper diagnosis and repair depend on this fundamental knowledge of how the component interacts with the vehicle's fuel system and engine management operations. Several potential causes can lead to the activation of DTC P0192. Firstly, an open VCC line, which refers to the power supply line to the fuel rail pressure sensor, can prevent the sensor from receiving the necessary voltage to function properly. Secondly, a short in the PF line, which is responsible for providing feedback from the sensor, can also lead to erroneous signal voltages being sent to the PCM. This can happen when the wire insulation degrades or a connector fails. Additionally, the fuel rail pressure sensor itself may fail due to wear or internal damage, resulting in incorrect voltage outputs. Lastly, a failure in the internal circuits of the PCM can also cause this error code to be set, as the PCM may misinterpret or fail to read the sensor data correctly. Each of these possibilities represents a unique challenge, and identifying the specific cause during the troubleshooting process is critical for an effective repair. When DTC P0192 is triggered, several symptoms may become apparent, indicating that there is an issue with the fuel rail pressure sensor. One of the most immediate symptoms is the illumination of the malfunction indicator light, or MIL, on the vehicle's dashboard. In addition to the warning light, the driver may experience a decline in engine performance. This may manifest as hesitation during acceleration, rough idling, or an inability to reach higher speeds due to improper fuel delivery. Another potential symptom is difficulties with starting the engine, as incorrect fuel pressure can lead to inadequate fuel being supplied at startup. Each of these symptoms serves as important clues in diagnosing the underlying issue, and recognizing them can help technicians arrive at a solution more efficiently. The first step in troubleshooting DTC P0192 involves checking the status of the ignition switch. It's important to verify that the ignition is in the on position, which is a necessary condition for the fuel rail pressure sensor to operate properly. If the vehicle has a keyless access system, the engine start-stop button must be in on mode for the onboard diagnostic systems to function correctly. This step is vital because if the ignition is not in the correct position, it would prevent the fuel rail pressure sensor from sending its readings to the PCM. Following this check, if the ignition status is confirmed to be correct, the technician should proceed to observe and verify the operation of the fuel rail pressure sensor as it pertains to the signal output voltage. Ensuring that the ignition conditions are met is crucial for accurate diagnosis. In the second troubleshooting step for DTC P0192, the technician should inspect the continuity of the VCC line that feeds power to the fuel rail pressure sensor. This involves using a multimeter to test for breaks or damage in the wiring. The VCC line provides the necessary voltage for the sensor to operate, and any interruption in this line could result in the low voltage output being detected, hence the DTC. It's essential to carefully examine the wiring harness for any signs of wear, corrosion, or fraying, as these could contribute to an open circuit. If continuity is confirmed, the next step would be to check for any short circuits or grounding issues along the line. This checks if there's a consistent flow of electricity to the sensor, allowing it to function effectively and relay accurate data to the PCM. Next, the technician will focus on the PF line, which is essential for the fuel rail pressure sensor's feedback to the PCM. It's important to verify that this line is free from any shorts to ground, as this can lead to incorrect voltage being read by the PCM. The PF line transmits the data from the sensor, indicating whether the fuel pressure is within operational limits. Using a multimeter, the technician should check the PF line for continuity and ensure there is no unintended direct connection to the ground that would skew the readings. Any faults found in the PF line can lead to significant issues in the fuel delivery system, as the PCM relies on this data to manage fuel pump operation. Attention to detail in testing this line is crucial, as even minor electrical issues can trigger this DTC due to signal anomalies. In the fourth troubleshooting step for DTC P0192, a focus shifts to the fuel rail pressure sensor itself. The technician must test the sensor to confirm it is operating correctly and providing accurate voltage outputs. This may involve providing appropriate power to the sensor and measuring its output using a multimeter. The expected voltage range should be clearly defined in the vehicle's service manual based on varying fuel pressures. If the sensor produces a voltage that does not align with the expected output as fuel pressure changes, it is indicative of sensor failure. Additionally, checking the physical condition of the sensor for any signs of leakage or physical damage is also recommended. If the sensor is determined to be faulty, replacement is necessary to resolve the DTC and restore functional operation to the fuel system, allowing the PCM to manage fuel delivery efficiently. The final troubleshooting step involves assessing the performance of the powertrain control module, or PCM, to confirm that it is functioning correctly. There could be internal circuit failures within the PCM that misinterpret signals coming from the fuel rail pressure sensor, resulting in the persistent DTC P0192. Technicians should use specialized diagnostic equipment to evaluate the PCM's operation. This sometimes includes checking for software updates or reprogramming if necessary. If no issues are found with the PCM or the sensor, the technician may need to consider potential wiring issues or connector problems that could affect signal clarity. Ensuring that the PCM is correctly interpreting the information it receives is essential for the overall functionality of the vehicle's fuel management system, and repairing this component may be critical if it's identified as the source of the problem. Please like and subscribe to the channel. See you next time.